Yes, so I did a postdoc in the computational imaging laboratory at Berkeley with Laura Waller, who is the pioneer of jointly optimizing the hardware and software to make microscopy more accessible to everyone. So I really liked that idea, and I was very inspired by a lot of their work. And so I think this does make a big difference in biophotonics. So for two reasons. First, the low cost part. So if we could use the recent advances in computation algorithms and machine learning to compensate for the high cost and low producibility of hardware, that would be amazing. Right, so that's happening in the commercial world. So like the watches we're wearing now and the phones we're using now, a lot of them are cutting down the cost of hardware and then compensate for the performance using software. And in the medical world, if we make that happen, we can definitely make this more accessible to primary office, to home use, and also to medical system in the developing countries. So that's the first point. And the second point, I think, is also a really powerful combination using optics, both optics and algorithms, because just using optical physics is sometimes we just hit the limit, the hard limit of physics. For example, you have to acquire that many points in your image, and your resolution is over there. So without the tricks from the algorithm or from the machine learning, it's just really hard to push. But if you already know that your image is bound to look like this, you can use that prior to reduce the burden from your hardware. And you can use artificial intelligence to learn that prior, to learn about your system, and even better, to optimize your system. Instead of using an ad hoc system design, you can now use machine learning to do an end-to-end optimization, directly targeting at your application to design the hardware in the most system application specific way. That would reduce your cost. And so I think that is a very powerful combination to further enhance the efficiency of application-specific imaging system. Yeah. So a lot of changes have been happening in the pathology world, where people are trying to use AI to help doctors, to help the pathologists to make decisions. So that is already a very active field. And then the other field that is emerging is just like you said, is the heaven of using AI to optimize imaging system. You're right. So I feel like that is also a very exciting area. So in my new lab, we're trying to cover both to see what is the sweet spot that can best leverage all the advances in optical physics, in engineering, and also in machine learning.